Welcome back to Docker series for developers. In previous video, we learned what Docker is and why it was created. We saw how Docker solves the famous "it works on my machine" problem by packaging applications into containers. But have you ever wondered what actually happens when you run a Docker command? For example, when you type docker run nginx, how does Docker know where to find the image? Who creates the container? Who starts the application? Today we will answer all these questions by understanding Docker architecture. Once you understand this architecture, every Docker command will make much more sense. Imagine you open your terminal and type docker run nginx. Within a few seconds, the nginx web server starts. But many things happen behind the scenes. Docker doesn't magically create a container. It follows a sequence of steps. The Docker client sends your command. The Docker daemon receives it. The daemon checks whether the image already exists. If not, it downloads the image. Finally, it creates and starts a container. Let's understand each component one by one. This is the high level Docker architecture. There are five important components: developer, Docker client, Docker daemon, Docker images, and Docker containers. These five components work together whenever we execute Docker commands. In next few slides, we will understand each component individually. The Docker client is what developers interact with. Whenever you type commands like docker run, docker build, docker pull, or docker push, you are actually communicating with the Docker client. Think of it as a messenger. The client itself doesn't create containers. Instead, it forwards your request to another component called the Docker daemon. The client can communicate with a local Docker daemon running on your laptop or even a remote Docker server. The Docker daemon is the heart of Docker. It is a background service that keeps running on your system. Whenever it receives a request from the Docker client, it performs the actual work. For example, building images, starting containers, stopping containers, creating networks, managing storage volumes. In simple words, the client gives instructions. The daemon executes them. Now let's understand Docker images. A Docker image is like a blueprint or recipe. It contains everything needed to create a container. For example, the operating system files, Java runtime, Spring Boot application, required libraries, configuration. An image itself doesn't run. Instead, Docker creates one or more containers from an image. Think of an image as a class in Java. A container is like an object created from that class. A Docker container is a running instance of an image. One image can create multiple containers. For example, suppose we have one Spring Boot image. We can start container A, B, and C, all from the same image. Each container runs independently. If one container crashes, the others continue running. So, where do images come from? Docker images are stored inside registries. The most popular registry is Docker Hub. Think of Docker Hub like GitHub. GitHub stores source code, Docker Hub stores Docker images. When Docker cannot find an image locally, it automatically downloads it from Docker Hub. Let's put everything together. The developer types a Docker command, the Docker client receives it, the client sends it to the Docker daemon. If the required image is not available locally, the daemon downloads it from Docker Hub. Once the image is available, Docker creates and starts the container. This complete process usually happens in just a few seconds. Let's connect this architecture with a Java application. Suppose we have developed a Spring Boot REST API. First, we build a Docker image containing our application. Later, whenever someone executes the docker run command, Docker creates a container from that image. Inside the container, our Spring Boot application starts automatically. The same image can be used by developers, testers, and production servers, ensuring consistent behavior everywhere. These are some of the most common in Docker interview questions. Interviewers may ask, what is the role of Docker client? What does the Docker daemon do? What is the difference between an image and a container? What is Docker Hub? And if you understand today's architecture, answering these questions becomes much easier. Let's recap today's lesson. The Docker client receives commands from the developer. Docker daemon performs the actual work. Docker images act as blueprints. Containers are running instances of those images. Docker Hub stores images that can be downloaded whenever required. In next video, we will explore one of the most confusing topics for beginners, Docker images versus Docker containers. We will use simple examples to clearly understand the difference. Thank you for watching. We'll see you in next video.